So we've evolved like Rory and Grant. We've evolved the title of the presentation a little bit over the last couple of weeks. So just so everybody understands, Group 2, we actually have offices in Edmonton, Red Deer, and Calgary. As was noted, I was a member of the associate in the firm up until 2010, moved back to Saskatchewan to start the Edmonton studio, Saskatoon studio, and became principal in Group 2. So we've been in Saskatchewan since 2010, so 7 years. We've evolved the studio from myself and my wife, Laura, up to 10 people now in Saskatoon. I'm going to sort of talk a little bit about the evolution of BIM in our office from design to the construction site, because we've found a lot of the power of BIM is not only from the design side, but the integration to construction. And the three projects I'm going to talk about are actually from Alberta. None of them are from Saskatchewan, but they give us a place where we can go, I think, as a province. There we go. So, I mean, we've all been hearing about BIM for many, many years. And when our firm started down the BIM road, we had lots of, was this the silver bullet? Was this going to achieve all of the great things we thought it was going to do? How are we going to get there? All that kind of thing. We got to invest in technology. We got to invest in training. How are we going to do it? Well, we decided in 2008, myself and two other people in our Edmonton office decided, we had a couple of workstations of Revit. We said, we're going to go down this path and we're going to find a way to make it work. So we needed a project that it would work on as a starting point. So Queen Elizabeth Pool was the first project. 2008, completed in 2011. We thought it was a good project because it wasn't very big for $1 million construction budget. It's also a seasonal building. So really the major parts of the building are architectural, structural, and electrical. There's no mechanical really in the building besides plumbing. So we thought, well, it's a good place to start to get the ball down the field a little bit. So here's a shot of the BIM model. At the time, we as a firm had structural and architectural together. We don't anymore, but at the time, so we thought, again, super easy. We get architects and structural engineers working together in the same model, no problem. Pretty easy to kind of, again, get the ball down the field. But the difficulty we had is that our mechanical engineer, when it came to the pool as the kind of L-shaped thing on the bottom, none of that is drawn three-dimensionally. Everything is drawn two-dimensionally. So we had to try and coordinate all of the three-dimensional objects that we had with the two-dimensional objects that they created for the pool. So that whole piece, the efficiencies that we see now using Revit, wasn't really there. It was really there because we started as a test case, so how we could use Revit. So we had some, I'm going to sort of talk on the three projects about sort of lessons we learned using Revit and where we have sort of evolved things over the years. So as I said, the first part was this 2D and 3D coordination piece. More and more, we are trying to do everything in Revit and doing it three-dimensionally, even trying to get our landscape architects to do things three-dimensionally, which is really, really hard. They don't like to draw things three-dimensionally, generally speaking. So, and as much we can do that as possible, the way we can coordinate those pieces together to really make them work. Again, all building consultants using Revit, that we've now sort of mandated as a firm on, I would say, 90% of our jobs, we don't allow our consultants to use AutoCAD because it's just, the efficiencies are just not there. So this was the first project where we really understood that's required. The other thing is, the architectural site plan. For the longest time, we've been drawing site plans in AutoCAD and then, merging them together with the Revit world. In Saskatoon, the Saskatoon studio, we've now stopped drawing all site plans in AutoCAD. Everything's done in Revit, so we can coordinate those things much, much better. So what happened there? Oh, there's a slide missing. Okay. So sorry, the next project is the Meadows Community Recreation Centre in Edmonton. 2010 we started it. It was built in 2014 by PCL. Very, very large team. We had consultants from Edmonton, Red Deer, Saskatoon, Toronto, Calgary, and Wisconsin on the job. so we thought, well, what's the best way to do this project? And honestly, Revit came to the forefront of our minds. Oops, sorry. So we tried to figure out the best way to break up the model to make it efficient. So what we ended up doing was we did an integrated model between Group 2 Architectural, Group 2 Structural, and Williams Engineering, who's our M&E consultants. And then we had federated models, so linked-in models for Perkins & Will, another architectural firm, our pool consultant, and Halco Yallis, who were the structural consultants. So we essentially had 4 models coming together with one model that was really, really big because it had M&E and structural and architectural in it. So very, very large model. So here's the distribution of the way the work was broken down. Group 2, we were the prime consultant, but we had it broken down such that we had a portion of the building that was sort of ours, and then the north portion of the building was Perkins & Will's architecturally, and then we had the various consultants on the job. We had a natural break in the building, which made lots of sense. We had an expansion joint along where the line is vertically, so that was the best place to break the model. But what we found was, when you put them all together, and the architecture, the base model in of itself was about 240 megabytes. It was a massive model. So just trying to get, we actually had to develop a schedule so that people could actually, when they would save and they would sync the model, they couldn't do it at the same time because they would actually crash the model. Even though at the time we were using, again, this is back before cloud was being done. We had a riverbed appliance to compress the information going back and forth between different consultants to make it work, but we still had to create an actual saving schedule so that we could actually make it all work. So there was a lesson learned right there. The other thing is that, as has been noted several times before, I mean, the biggest piece that we've seen is the coordination of all the elements. And this is a shot from Navisworks. Our Navisworks model, you know, all of the green is mechanical pieces, rooftopping, it's those sorts of things. That was where we found the power, especially because this building has really no ceilings. Everything is exposed. There's lots of exposed piping, there's lots of exposed ductwork, all those sorts of things. So if you're going to build that, you need to coordinate it. So we spent a lot of time, as you can see here, marking up things where, you know, we had to move the piping, relocate piping so it would go under beams and go under ductwork because none of it's hidden by the ceiling. All of it's exposed. It's got to be done right. We also spent a minimal amount of time. This was our first job where we actually did true clash detection. We did it, I would say, sort of near the end of the job, which was probably, again, lesson learned, not the right time to do it. It was a bit of a test case on doing true clash detection. It gave us a bit of a starting point. Did it fully pay out for us at the time? No, but what it did help us to learn was that we needed to do it earlier on in the process to create true clash detection going forward. So as I said, lessons learned, integrated model, size and speed. The other thing that we had, our BIM execution plan was very, simple. And we constantly were getting the consultants to make sure they were executing the project as was described in the BIM execution plan. Because it was one of the first times a lot of them had done BIM on this scale, they were having a little bit of trouble knowing when they had to have certain things in the model, when they didn't. You know, you're at a 50% working drawing stage, what needs to be in at this point and what needs to come later. So we spent a lot of time working with them to understand what needs to go in at that point. Again, clash detection was a big one. The other one was that we provided the Navisworks model to PCL, to the general contractor. And we did that to try and help with visualization of the project. But what ended up happening was, good or bad, PCL started using that model more to help them understand things. But then all of a sudden, a whole bunch of questions started coming from the model. But the model was never intended as a model that could be truly used for construction. At the end of the day, this was an export to 2D drawings to provide a set of tender documents where you could tender the project and build the project from. So that's another piece that we learned a lot about. We have to make sure we're very clear with our terms of reference when we're handing over models to the general contractor, so that's very clear on what that model's intent is, so that we don't get questions kind of coming about it later. So last project I'm going to talk about is a project that we've completed recently, 2016, St. Joseph's High School in Red Deer. I'm glad that Rory sort of gave an IPD primer earlier, because I'll talk a really little bit about IP. I don't have to expand on it too much, which is kind of nice. So we were contracted by Red Deer Catholic Schools to deliver 2 schools, both under an IPD contract. So one of the differences, I think, maybe between Moose Jaw and this was we actually had 14 signatories to the contract. I think Moose Jaw was 3 or 4, correct? Oh, 6. Okay, there you go. So we had a lot of our major subtrades were actually signatories to that contract. So the contract is with the owner, the consulting team, the general contractor, and some of the major subtrades. So here it's 14. There's some projects we're doing right now in Alberta. I think on the Red Deer fire halls, I think we've had 22 signatories to the contract. So everybody is tied together through the contract. And what the power of that is, everybody really has to pull in the same direction because we're all contracted together. No one is off in left field and where you can point fingers at that person because they're not part of the team. Everybody's part of the team. So we find this is one way that we think, and then leveraging BIM on that front, we can really get far down the field with constructability in BIM and cost saving. So the total project budget at the time of validation was $51.1 million. Delivering the 2 high schools, we've actually come in at $47.8 million. So we've come in $3 million under budget, and we've given the owner way more than they actually had wanted. There were several things they put into the contract through the process, furniture things, addition of commercial kitchen equipment, a whole bunch of things because they had extra money through the process because of the efficiency of the process. And I'll talk about that a little bit. So why did we use BIM through this process? Well, I think as been noted by PCL and the Stantec team, one of the things you need to do is we have a unique structure, but you need to build it in the computer. You need to virtually build it first, and then you can build it on the job site. Honestly, get through all the wrinkles, hopefully, when you build it virtually, and then you can make an efficient building process. And then leveraging sort of lean tools, as Rory described earlier, things like pull planning and different things like that we can actually leverage to make an efficient construction process. Putting all that together, can we provide value to the owner? So the tools that we used on these projects, obviously Revit, Autodesk 360, Navisworks, AutoCAD. We used Trimble quite a bit for surveying because a lot of the day-to-day different things with the general contractor was surveying constantly so we could keep an up-to-date sort of as-built model as we were going through the process. We co-located on-site. One of the key things that we did on the first school was to build basically a sort of a big shop, so to speak, that became the site office, our big room, so to speak, but also then became an amenity for the school once it was done. But it really provided a great place. You don't got to rent trailers, all those kind of things. But we were able to co-locate together subtrades, engineers, architects, contractor, client, everybody in one place many, many days of the week to make sure that we are all on the same page. On-site computer stations, tablets, iPads, a lot of the trades were given iPads to be able to use virtually on site to look at different things. We had a pretty good uptake on that front. Lots of trades were a little bit hesitant to do that, but there were no drawings for this job. Everything was built from the model or from other models that were added to that model. So there was not a single drawing that we added. Interestingly, we didn't even do a submission to the City of Red Deer using a drawing. We actually brought them to the job site, ran them through the model, and actually walked around the site with them to look at specific things. So they didn't actually approve us for a building permit with physical drawings, which is relatively unheard of. So the process, again, use of building design, using modeling and design, and on through construction. To Roy's point, I think as architects, we're really good at using modeling for design, but the question is always, how does it go into construction? Because I think, honestly, that's where we're all going to find savings in this industry to leverage it better for the owner, to give them really what they're looking for, again, to help them understand what they're getting, but also to make sure that their project hits the budget, it's on time, all those sorts of things. That's where we can provide true gains. But we asked lots of questions to the contractors, like what do you need from the model? Because again, one of the things I think we're good at as an industry is we want to model everything. It's actually not efficient to model everything. There's certain things you don't need to model, i.e. we spend lots of time as an industry detailing millwork out. We don't need to detail millwork out. You know, the millworkers know how to build it. We got to provide them with a spec. We can probably do a lot of it through 2D drawings. That's the best way to get millwork done, instead of us spending a whole whack of time detailing and detailing and detailing for no apparent reason. And then handing it off, like what do they need when we hand it off to them? And then what's that output? So I'm not going to go into too much detail here, but we had a very robust BIM execution plan at the beginning, and to the sort of the dashed lines on the bottom, we had to talk about items that were very, very sort of data-centric, very, very heavy from a size perspective, against things that were very, very light, sort of 2D versus 3D, and how we integrated those pieces together using things like A360, and then exporting certain things to Navisworks, all that kind of stuff. But we spent a lot of time on this, and then working with the general contractor and the trades to help them understand how that was all going to work together. Every project we have to talk about level of development, and this project was no different, because I think we actually spent a lot less time building things to a really high level of development and building things to a lower level of development, and then allowing the trades to build it to that higher level of development through their fabrication models. So we would provide them essentially with a framework at maybe an LOD 200, LOD 300, but then when it comes to fabrication, they would take it and to produce something that was maybe LOD 350 or even further, because that's where the power is. Because there's no point, again, in us spending a whole whack of time getting things to a certain level and then having a subtrade go back and take it and rebuild it again. How do we make an efficiency in the process? Again, clash detection, I mean, this is like a, Revit BIM buzzword. We spent a lot of time, although here, doing clash detection, and that's the great thing about integrating with the general contractor in the job site, major subtrades, all those sorts of things, sitting down, going over the model with everybody to talk about clash detection and resolve the clashes before we get to the job site. And then precision layout. We spent a lot of time surveying. The surveyors on the job, we had one specific guy from this, our project was with Shandos Construction, who basically every single day he was just shooting survey points so that we could ensure that our model was up to date. We had an up-to-date model, as-built model that was always, every day on the job site, it was today's model. There was no, we tried to eliminate the whole idea that, oh, that's been changed, but we never got it updated in the model. It was very, very precise. One of the terms that we've used through the process is called source of truth, and you can sort of see it here. We had this is an amalgamation of our Revit model and then the Tekla model from the steel fabricator, and some things had to move because of just constructability, those sorts of things. But the question is always, again, back to the surveying, which is the source of truth. At the end of the day, the typical project, it's going to show the Revit HSS here. But then the Tekla model or the shop drawings are going to show the HSS here. Well, we were constantly, again, updating that model to make sure that we had the latest information, overlaying different models to make sure that the information was correct. And one of the things that I've heard a lot about is how we can do things efficiently, and we totally can. But at the end of the day, good information in equals good information out, or crappy information in equals crappy information out. You got to build it right at the beginning, and you got to know what you're building it for. One of the things, the little thing on the right, if you look at the naming conventions and a whole bunch of the pieces in there for a wall type, we didn't need any of that stuff, but it created a confusion within the model. So we had to find a way, again, to simplify certain things that we were doing to make sure that that information that goes in was going to be helpful and going to work for the subtrades when it got to the job site. So lessons learned on this project are huge because of the integration to the construction. Elimination of rework. One of the things we did here, we talked about millwork, but one of the big ones was pre-cut steel studs. We actually had the steel stud guys basically create packages of steel studs that were just-in-time delivery. They would be pre-cut, they would arrive at the job site, they knew where they were installing that day, and they would basically put them out with little to next to no cutting. The only places that it became maybe an issue is around windows and doors, but even then we started getting them into the point of we knew exactly how long those studs had to be at those locations, so they were able to put them together in packages, just-in-time delivery, like at the car industry, and bring them to the job site when they needed them. A huge efficiency there from their perspective, because they don't got to cut. All they're doing is installing. So it makes a huge difference in the construction cost and the speed of construction. Co-location. I think we always think about, you know, project managers and architects and engineers in a big room, but the more we've tried to do this, the more that we've said it's not just those guys, but it's also the technologists. It's also the contractor foreman. All of those people need to be in the room together working. Not just people who are overseeing things, but people who are doing the work. That's the critical part to getting this done efficiently, because we could then, you know, response times to queries or questions or whatever the case may be, we could almost do it instantaneously. Construction site to production site, that was probably the biggest piece for lesson learned for me, is that, you know, we can leverage this to make an efficient construction. We can build in the computer. We can then leverage that on the job site. We can do things like prefabrication, way more prefabrication with this, things like ductwork and all those sorts of things, because of an accurate model when it was all said and done, leveraging the use of BIM to its fullest. And efficiency honestly saves everybody money. These projects are IP projects are great because you're all tied into a contract. So at the end of the day, you know, if one group is having difficulties in a job, it's up to everybody else to help them, to bring them up, because when it's all said and done, everybody's profit is at risk. Everyone has profit here, but it's at risk depending upon how well the project goes. So if we can find ways to be efficient by the use of BIM, the use of prefabrication, all those sorts of things, we could all make money, give the owner what they want, give the owner a project that's ahead of schedule, all those sorts of things. It's a win-win for everybody. So sort of the last slide, lean IPD versus traditional. $35 million project, $33 million delivered it for traditional. Hopefully you'll get it for 35, you might get it for 40. So construction, schedule, we were able to, you know, essentially get from the validation point to construction start in 10 months. $500,000 to actually achieve cost certainty, 18 months to occupancy, profit was defined right at the beginning, shared risk and reward, less finger pointing saying it's your fault, no it's your fault, no it's your fault. It's everybody's job to figure out how to do it right, so that then the risk is really shared by everyone. We had no RFIs and we had one single change order on the job. All because of the process and because of the integration of BIM. So, that's it for me. Thanks.